I said it before, uncertainty is a richer domain than risk. And you can compare that with outcomes again. The domain of non-monetary outcomes is richer than the domain of monetary outcomes. Same way, the domain of non-probabilized uncertainty is richer than the domain of probabilized uncertainty. I'm sure you can confirm this experience from your private life. For risk, we usually assume one risk attitude, one probability weighting function. Well, for gains, let's assume. So one probability weighting function. And of course, this doesn't hold perfectly empirically. There have been quite some studies showing that if you have outcomes that arouse all kind of emotions, then the probability weighting function can become different from it. And you can have for life duration can be different than for money, and even within money, for big money amounts, it can be different than for small money amounts. All these things are happening. But here we're going to choose for pragmatism and tractability, because if you have a model too general, you can't work anymore. So you have to make some assumptions. And assuming one probability weighting function for a risk, it's not very bad. It's not a very bad approximation, especially if you take the emotion neutral outcomes. This is plausible, and then for protectability, we're going to do it. And again, comparing with outcomes, we usually assume one utility function of money for a consumer. Well, in reality, in a situation that arouse different emotions, the utility function will be different. But then we have to have tractability, so we still assume it. And that we continue to do. However, assuming one uncertainty or ambiguity attitude for all non-probabilized events, there's no way. This really cannot be. It would be very nice, life would be very easy, but it's just too rich a domain. And the same with commodities. One utility function for all non-monetary commodities, no way. It's too rich a domain. This just cannot be. Therefore, we just have to reckon with different attitudes, different pessimism, whatever it is, for different kinds of events. And for instance, we're going to study soon to come that you have more pessimism, more source preference maybe for one source than for the other of events than for the other source of events. We're going to define that next. So that's a comparative result. But you may notice that this is a comparative result within subject. We have already seen also with expected utility, we had comparative results. One person can be more risk averse than the other, but this was between person comparisons. Here with uncertainty, we also, well, there are between person comparisons also, but we even have to do within person comparisons. One source is different than for the other, also within a person. And that this is a novelty of uncertainty. With risk, we didn't really have that. We can be a bit pragmatic, but with uncertainty, we have to do it. So here, and I already announced previous recording that now I'm going to present you things that are different for uncertainty than for risk. So here, uncertainty is much more general. For uncertainty, we have to define it. And that's what we're going to look at next to come. So in general, a source of events is a subgroup of events, and vaguely speaking, is events related to a similar kind of uncertainty, having similar characteristics. Mathematically speaking, it's a new primitive in the model. That's not so nice. You have to define something new, you have to think in application, what should it be? But it cannot be avoided. Again, if I compare with outcomes, commodities in consumer theory, you have to define what are commodities, and that has to be done at the modeling stage, and there's no clear how should you do it. You just have to do it. Maybe you take fruits as one commodity and clothes as another, or you take pants and shirts. It's something to be decided at the modeling stage. You have to decide which kind of event you treat as one and compare it differently to others. Anyway, formally speaking, source is a new primitive. And for the mathematically oriented listeners, I'm going to assume always that sources are algebras, so they are sub-algebras of events. That means I'm assuming that if you take unions, intersection, and complements of sources, events, then you stay within that source. It's to have a sort of bit of richness in that regard, just to have that we can easily do work. So that we're going to assume. So now I turn to comparative results. Imagine we have two sources of events, A and B. Maybe A is foreign stocks, B is domestic stocks. Or maybe you're looking at the Ellsberg paradox. You say A is the unknown ambiguous urn, B is the known urn. It can be many things of that kind, but let's assume two in abstract two sources A and B. And imagine that we observe this B weakly preferred to A. Now, B and A denote events, and it's implicit in the notation that B is an event from source B and A is an event from source A. And I hope you remember this inequality. It means in the gambling on sense. If there's a good, actually, I'm interested only talk about gains for the now. If there's a good outcome that you can choose, either you get it if event B happens, or you can get it if event A happens. You say, I'd rather have it on event B, so I'd rather gamble on event B. Then we denote it this way, the revealed likelihood relation. And you may also remember this is just the ordinal nature of the event weighting function. This means the event weighting function of B is weakly exceeding that of A. Imagine we make such an observation. Can we say, conclude, or at least take it as a suggestion that there is a systematic preference for the uncertainty of source B over the uncertainty of source A? Some sort of maybe more optimism for source B or whatever it is, and not really, need not be. We cannot, it's too soon to say. For instance, it may well be that this person has a systematic preference for the handling uncertainty of source A rather than of source B, but just the case is that particular event capital A is very unlikely in the subjective perception of the subject, which is maybe not defined yet, but give me that one. And event B may be very likely in the perception of the subject. So it may be not a matter of source preference or whatever. It may be just a matter of belief. There's more information supporting B than supporting A. So we cannot infer much from one such observation because beliefs are intervening. We rather do something where we sort of control for beliefs. And now I'll show you an example how that can be done. Imagine we make two observations. We indeed observe event B is preferred to event A in the gambling on sense. Formerly this was called revealed preference, revealed more likely. Sorry. And we also have a B complement. If we have these two observations together, then the belief explanation is not very plausible, because if you have more information supporting B than A, that means automatically more information is against B complement than A complement. It's a bit vague, I didn't really define it, but give me that one. So anyway, if we make this combination of observation, then we say it can't be just belief. There must be more going on. So this is at least suggesting that there's a systematic preference to handle the uncertainty of source B rather than the uncertainty of source A. So this can sometimes happen then. But imagine, so it's suggested, imagine that we sometimes make such observations, but we never make the opposite observation. So sometimes this happens, but never we have the other way around, that you rather gamble on the event A, but also on A complement for a particular pair of events where A comes from capital for source A and B comes from source B. This would suggest source preference for A over B. But imagine that this never happens. So sometimes we see things suggesting source preference for B over A, but never this. In that case, we say we define this formally as a source preference for B over A. So this can happen. But this is excluded. Then we say source preference. So we do allow for that, but this is never happening. That's the mathematical definition of, well, maybe you interpret as more optimism or whatever, but we call it source preference for source B over source A. And in terms of the weighting function, we can rewrite it, because this means that the weighting function at A is weakly exceeding the weighting function at B. And this is the weighting function at A complement strictly exceeding the weighting function at B complement. So we can rewrite that condition in this manner in terms of weighting function. If A has at least as much weight as B, then it must be that A complement has less weight. So that's another way, of course, is logically equivalent to what I wrote here. So these are the formal definition of source preference. And you've seen examples already. For instance, the Ellsberg urn. People rather gamble on the red from the known urn than red from the unknown urn. They also complement of red being black. They also rather gamble on black from the known urn than black from the unknown urn. So that was suggesting source preference for the known urn over the unknown ambiguous urn. But we never have the other way around. So then we can say we have source preference for known probabilities over unknown probabilities in the Ellsberg urn. This was known versus unknown. This ambiguity aversion is often defined that way. So in this course, ambiguity aversion simply means source preference for known probability uncertainties over unknown probability uncertainties. That is ambiguity aversion. This is a special case of source preference. Another example was in finance. There were domestic stocks and foreign stocks. Here, neither of these two need to be probabilized. But then you rather gamble on the domestic stocks going up rather than the foreign stocks going up, but as a complementary event. domestic stocks going down rather than foreign stocks going down. And the reason is you feel more familiar with an uncertainty about the domestic stocks. You have this domestic preference for handling such kind of uncertainties. So there are many cases where this happens, and we'll study it and do things with it. You can do similar comparative things with insensitivity. There can be more insensitivity with respect to one source than with respect to the other. That is, one source has vaguer information, more ambiguous information, or more complex, whatever it is. The other person is just understanding less of one source of uncertainty than of the other. So that is a comparative result for insensitivity. It can be defined. I will not do it. We have no time, but you can imagine, and it's mathematically more complicated than this source preference, but it can be done, and it's also being studied. Well, these are a few concepts that I defined, and this is quite research going on today. Different authors, different people define these things a bit differently, especially more insensitive. It's a new concept. The empirical reality imposed it upon us. We didn't study or think about it before. So many people have different interpretations. Is it only degree of information, or is it also cognitive ability of the decision maker? Those are all things that are being discussed and studied. And this also means for listeners who want to do research, these kind of topics are still going on, so you can do research there. And we need more research to come. Well, this will be continued in the next recording.